My name is Mr. Farr, and I teach 5th grade at Mount Olive Elementary School. This activity is Activity 1 for summer for science for 5th grade. Activities and handouts can be found under the Student Resources tab on the Knox County Schools website, www.knoxschools.org. Feel free to show us what you've learned and tweet at KCS Science. If this video is hard to understand, turn on the closed captions if available, adjust the playback speed to slow down the video, consider watching the short clips, then pause, listen, and watch again. Ask someone in your home to watch the video with you. Stop frequently and talk to your partner about what you heard and understood. I'd like to take another second to introduce myself a little more right here. Like I said, my name's Mr. Farr. I teach 5th grade at Mount Olive Elementary School, and I went to Mount Olive Elementary School, and I went to 5th grade in the room that I teach 5th grade in now. So I think it gives me a unique perspective with my students. And as I was reflecting on this lesson, I was thinking about how I'd never taught a lesson from my home before. And then I was thinking about how you guys are going to be watching this lesson from your home. So we all have that in common, and I think that's kind of cool. So let's get started. Anybody that knows me knows I like a good meme before a lesson. You're tall enough, they said. It'll be fun, they said. Narrator, it was not fun. So you can tell from the picture there, the kids may not be having as good a time as they were hoping to. And that clue probably gives you a clue that our lesson today is going to involve roller coasters. So we're going to talk about roller coaster science today. Some of you may have ridden on a roller coaster, maybe at Dollywood or the fair. Some of you might not have, and that's okay. The science standard today is to test the effects of balanced and unbalanced forces on the speed and direction of motion of objects. So our central question today, how does the height of a roller coaster affect the coaster car's speed when it moves around the track? Take a little think time on that. So we're going to start with a warm-up activity. For this activity, you will need a toy car with wheels that spin. You may pause the video if you need to go get anything. Step 1. Place the car in front of you so you're looking at it from the side. Step 2. Use your right hand to push the car to the right. Step 3. Use your left hand to push the car to the left. Step 4. Put both hands on each side of the car and push with the same amount of force. Before beginning, make a prediction about what you think will happen during each step. After each step, record your observations. We're going to send it over to the lab to watch a warm-up activity.
Hey guys, welcome to the lab. You see I'm here today with my fire truck. Anybody that's ever been in my class knows one day when I grow up, I'm going to be a fire truck. This particular fire truck was made by a former student. Shout out to you, know who you are. And I'm going to use it to demonstrate our warm-up activity today. As you can see, when the fire truck sits on the table, it doesn't move because the forces on it are balanced. However, if I take my right hand and push it to the right, the fire truck goes to the right. If I take my left hand and push it to the left, it goes to the left. And this is because the forces are unbalanced when I only push on one side. If I take both hands and push on both sides with the same amount of pressure, the forces are balanced again, so the fire truck doesn't move. Thanks for stopping by the lab today. I hope to see you again soon.
Okay, so think about it. When the car is sitting in front of you, the forces on the car are evenly balanced because zero force is being applied to either side. However, when you push the car with either hand, you create an unbalanced force because one side of the car is being pushed and the other side is not. This allows the car to travel in the direction it was pushed. When you pushed on the car with both hands using the same amount of force, this created a balanced force because the car was receiving the same amount of force on each side. Let's think about a roller coaster. Is the force on the roller coaster car balanced or unbalanced as it sits still in the station? Is the force on the roller coaster balanced or unbalanced as it goes up the hill? Is the force on the roller coaster balanced or unbalanced as it goes down the hill? Let's experiment. You will need a toy car with spinning wheels. You can use the same one from before if you want. A long piece of cardboard or a similar material for a ramp. 3 objects of varying heights. For example, stacks of books, a footstool, a box, or similar objects to lay the ramp on. And a ruler or a tape measure to record height and distance. Feel free to pause the video while you gather your supplies. Step 1. We're going to lean the piece of the cardboard along the top of the smallest object to make a ramp. Tape down the edge of the cardboard to the floor if you need to. Step 2. Place the toy car at the top of the ramp. Release the car. Step 3. Measure and record the height of your ramp and the distance the car traveled across the floor in the table on the following page. Next, move your ramp over to your second highest object and repeat steps 1 through 3. Finally, move your ramp over to your highest object and repeat steps 1 through 3. Before you begin, make a prediction as to which ramp will cause the car to travel the furthest distance. Here's the table you can fill in. It doesn't have to be exactly like this if you want to make it your own. Go ahead. And we're going to head back over to the lab for another experiment.
Hey, welcome back to the lab. I'm going to kind of model the experiment for you today in case you have some questions about how to get it done. So the first thing I did, I went and found the 3 thickest books in my house. Now I'm going to set them down here on the ground. I'm going to measure them because I want to know how tall this ramp is. So I put my measuring tape on there, and it is right at about 6.5 inches. So I'm going to record the height of my smallest ramp on my chart. Then I get some cardboard, lay it up right here, get it ready. And I gotta be honest, I was gonna use my fire truck for this experiment, but as you can see, the front bumper comes down here below the tire, and when I would put it on the ramp, it would go down and hit the carpet and stop. So that wasn't gonna work for this. And that's how it is sometimes in science. Sometimes the plans you make don't work out, and that's okay. You improvise, you adapt, you overcome, you observe, you experiment again. Remember, it's okay to make mistakes. That's how we learn. So, since my fire truck wouldn't work, I got a monster truck. So I'm going to take my monster truck, put it here at the top of our ramp. Now, right now, the forces on it are balanced because I'm holding it still, but when I get let go, the forces will become unbalanced. All right. So we see how it took off down there. Kind of hit the couch. That's okay. I'm going to go ahead and measure about how far it went. And it looks to me like it went about 45 inches. So I'm going to record that here on my chart. Uh-oh. 45 inches. And I'm going to go ahead, I'm going to get a little bit taller ramp. Grab a footstool. You probably have a footstool, something similar at home. Anything that makes it taller. If you don't have anything else, you can just keep stacking up books. Go ahead and lay my ramp up there. I want to record the height of my ramp. Measure that out. About 15.5 inches. Go ahead and record that on a chart. Get my monster truck here. Make sure my ramp's situated. Put it at the top of the ramp. I'll let go of it so those forces are unbalanced. Oh, wow. So it definitely went a lot farther, all the way to the grandfather clock. Let's see. I'm kind of measure from the end of the ramp. All the way to here. Again, it doesn't have to be perfect. Do the best you can. Looks like about 115 inches. So pretty far. Definitely seems like the height of the ramp affected the distance that the car traveled. It also looked like it was going faster. So, let's try one more time with the tallest ramp. So I've got my drum here. You might not have a drum, but I bet you have something similar. In my classroom, we use a drum for a lot of different reasons, and the star of the week gets to play it most of the time. And so I thought I'd bring the drum in here. Again, makes it pretty tall. Go ahead and measure my drum's height. It's right at 2 feet tall. So 2 feet, that's 24 inches. I want to record everything in the same measurement so it's easy to compare my data. 24 inches height. Got my ramp there. Set it on there. Let's see what happens this time. Oh, okay. Kind of got a little squirrely there, didn't it? Give it one more try. Oh, wow. Oh, man. Goodness. Off the screen, pretty much. I don't even know how I can measure that. I'm going to kind of start at the car, work backwards this time. And so this one, wow. Right at 11 feet, or 132 inches. Let me record that on my chart. So, if I kind of analyze my data there, I can definitely see a relationship between the height of my ramp, the distance that my car traveled, and through casual observation, I also noticed that it seemed to increase in speed as it went downhill, from the smallest to the tallest ramp. So that's something to think about as we're answering that essential question. Thanks for stopping by the lab. Hope to see you again soon.
So, was your prediction correct? What could this information tell you about the height of a hill on a roller coaster? Take a little think time. Think back to our essential question. How does the height of a roller coaster affect the coaster car's speed when it moves around the track? Go ahead and write down your answer to that one. You can draw a picture if you're not comfortable writing. So I just want to say thank you for learning with me today. It was a lot of fun. I want to give a shout out real quick to my class. Seeing you guys the other day on Sign Delivery Day was one of my best days as an educator. So I hope you guys have a great summer. I hope everybody does. Stay safe out there. Try to have some fun, and I can't wait to see you soon.